Okay, so today we're going to look at hypothesis testing for the geometric, and we're going to do finding critical regions. Now, this is going to require quite a bit of log knowledge, so I'm hoping your logs are all up to date, okay? If not, you need to go back and have a look at logs from year 12, make sure you're hunky-dory with them, okay? So let's do this example. I'm just holding it up so you can see it. Let's say Alice rather than Aisha. Alice wishes to test if a five-sided spinner numbered from 1 to 5 is fair. She spins the spinner and counts the number of trials until she gets the spinner to show the number 1. Using a 5% significance level, find the critical region for a one-tailed test of the hypothesis that the probability of getting a 1 on a single spin is less than a fifth. Okay, so as always, we're going to set up our distribution. So x is going to be the number of spins until getting a number 1. And our null hypothesis is going to be that it's a fifth. The probability of getting a 1 is a fifth. And our alternative is that it's less than a fifth. Okay. Let's set up our distribution so we don't mess it up. So our x is geometrically distributed with a probability of a fifth. Okay, so if we want our probability to be less than a fifth, we need to work out what x has to be more than. Okay, so we're going to do you remember it's because like the hypothesis testing I just on the video from last lesson, it's the opposite way around, because as p is decreasing, our mean needs to be increasing. So we need our mean to be increasing. So we've got to find what number this has to be in order for the probability of this to be less than our significance level, which is 5%. Okay, now from the key points which I've given to you, I put on showing my homework when you were doing the negative and binomial mixed exercise, negative binomial and geometric, mixed exercise. In order for this to be true, then the formula we are going to use is this: 1 minus p to the power of x minus 1. Okay, so we need this side is going to be this, so that is 1 minus a fifth to the power of c minus 1. We need that to be less than 0.05. We need that to be less than 5%. So obviously that's 4 fifths, or 0.8. Okay, right, now this bit's quite special. This is where we're going to use logs, okay? So I'm going to take logs of both sides. It doesn't matter what base e, base 10, doesn't matter. So log of, let's call that 0.8 because that'll be easier, c to minus 1 is less than log of 0.05. Now hopefully you remember the log laws, that if you've got a power, that brings it to the front. So that's the same as c minus 1 log of 0.8 is less than log of 0.05. Okay, now it's just a rearranging, but because it's an inequality, you have to be very careful. If you do on your calculator, log, doesn't matter what base we're in really, log of 0.8, that is a negative number. So when I divide, don't forget when you divide by a negative, this has to flip over. So it's going to be c minus 1 is bigger than log of 0.05 over log 0.8. Okay, so then c obviously just has to be bigger than 0.05 divided by log of 0.8 plus 1. Okay, and if you just bung that into your calculator, so we've got log, I'm going to do log in base 10. Oh, blimey, mess that up. Log in base 10 is much better. Well, not much better, sorry. It's our standard one. You could do luns if you want to do luns, natural logs. Oh my gosh, I'm in the right old pickle. Here we go, plus 1, fat thumbs. And that is that c has got to be bigger than 14.425, blah, 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 blah. So that means our critical region, obviously you can't have the 14.4th turn, so we're going to say that x has got to be greater than or equal to 15. That is our critical region. Okay, part B says find the actual significance level. So for the actual significance level, we are just going to work out the probability of that happening. So we've still got our geometric distribution of a fifth, and we want to know the probability that x is greater than or equal to 15. So we're going to do 1, which is 1 minus p to the power of x minus 1. So 1 minus a fifth to the power of 14. And when you do that, you should get 0.0440. So our actual significance level is 4.4%. Okay, Right, let's do a second example of critical regions. So here we go. In a particular city, a lobster card is used as a method of payment on trains. Clever. The company that administers the card claims that 1 in 1,000 cards will be rejected by the card reader at the train station. The train station manager feels the company is understating the proportion of cards rejected by the card reader and decides to carry out a test. When he comes on the shift at 5 AM, he counts the number of passengers who pass through until he notes a passenger who has a lobster card rejected. Using a 5% significance level, find the critical region for a one-tailed test of the hypothesis that the proportion of lobster cards rejected by the card reader is greater than 1 in 1,000. Okay, so same old, same old. So we've got X being the number of cards read by the reader until 1 is rejected. Our null hypothesis is going to be 1 in 1,000, so 0.001. And our alternative, he thinks they're understating, so he thinks that the probability is actually going to be greater. Okay, set up your geometric distribution. I keep writing geo wrong. 0.001. And it's a 5% significance level. So if we think that P is greater, that means we want to need to work out what is less than. So we're going to do probability that X is less than or equal to C needs to be less than 0.05 because it's 5% significance level. Okay. Recall from our notes, our key points, that this is the formula for the less than or equal to. Okay. So that means we've got 1 minus 0.001 to the power of C needs to be less than 0.05. So that's 1 minus 0.999C is less than 0.05. And I'm going to shimmy that over there, shimmy this over here. So I've got 0.95 is less than 0.999C. Okay, and I'm going to take, oh no, I've just logged out. Does it work still? Hopefully you're still with me. Then I'm going to take logs of both sides. So we've got log of 0.95 is less than log of 0.999C. Bring the C to the front. C lots of log 0.999. And again, when you're doing this, you need to check and see if that's negative, this log of 0.999. So log in the base 10, 0.999 is negative. So when I divide it, my C is going to flip over. So log of 0.95 divided by log of 0.999. Okay, and that means that C has got to be less than whatever that is. So log in the base 10 of 0.95 divided by log in the base 10 of 0.9999. Oh no, too many nines. So that means that C has got to be smaller than 51.26. So that means that because it's got to be smaller than, X must be less than or equal to 51. Okay, that is your critical region. Okay, same thing again. Write down the actual significance level of the test. Well, the actual significance level is the probability of that happening. So the probability of X being less than or equal to 51, which is just, if we're using our formulae, is that. So it's 1 minus 0.001 to the power of 51, which is just 1 minus 0.999 to the 51, which is 0.497 to 4 decimal places. So that means the significance level is 4.97%.